All right. So to complete this problem, the first thing they want me to do is make a probability model for the discount. So I'm going to let's use D. Let's be a little more meaningful instead of X. I'm going to let D be the discount received. And in order to make a probability model, I basically, which just kind of looks like a little chart, I basically just list all of the D's or all of the possible discounts that could be received. So we could receive no discount, we could receive $10 discount, or we could receive $20 discount. Next, I need to find the probability of each one of these discounts occurring, and that's what we're going to list here. So the probability of the discounts. Now, in order to find these probabilities, I need to think back to chapter 14 where we learned how to do probability of picks, random picks. So there's 4 scenarios, well there's 3 scenarios technically, but we're going to combine some events for some of these. All right, and the easiest ones are if we pick the ace of spades or the ace of clubs. Both of those will produce a $0 discount, and that probability is just 1/4 for the spades, 1/4 for the club, so that's 2/4 together total. So I can leave that as 2/4, or I could write 1/2. This would result in a $0 discount. Now, I'm not going to write it down here just yet because there's actually another way that I could end up with a $0 discount. So I'm not going to put it in yet. I got to combine that with the other possibility for a $0 discount. And the other possibility is first we pick the ace of diamonds, and then we don't pick the ace of hearts. We pick the ace of diamonds, and then we pick the ace of spades or the ace of clubs. That's another way of resulting in a $0 discount. Now, this is an and, okay? And so we need to think about conditional probabilities when we do and. First one, probability of ace of diamonds. There's just one ace of diamonds, but we're going to multiply that, the probability of picking an ace of spades or an ace of clubs, knowing we've already picked an ace of diamonds. So you got to imagine this card is no longer in the set. So now the probability of this second event occurring, which would be these two, has a 2/3 chance of occurring because there's only 3 cards left, and 2 of them would produce ultimately the $0 discount. So that's 2/12 or 1/6. This is 2/4 or 1/2. These two will combine to give me the probability of a $0 discount. So I'm going to go to my handy dandy little calculator here, and you can reduce them or add them, not reduced, it does not matter, and I get what's going to turn out to be 2/3. So the probability of getting a $0 discount is going to be 2/3. Now, the $10 discount comes from first picking that ace of diamond and then picking that ace of hearts, because, hey, at least it's red, and then you do have a better chance now, so they're not going to give you the full discount. So using the same similar techniques that we just did here, the ace of diamonds has a 1/4 chance of being selected, but now you need the ace of hearts to be selected on the second pick. Once again, the ace of diamond is out, so all you have now is 1 ace of heart out of 3. So that's a 1/12 probability. That would result in a $10 discount. And the last one's pretty easy. We just want the ace of hearts on the first pick. That's just 1/4, and that will be our $20 discount. So we had to kind of use our probability rules that we learned last chapter to make our probability models. Sometimes they're a lot easier than that. I might tell you these probabilities in the stem of the problem. That makes it a whole lot easier. For this one, we had to use our probability rules that we learned last chapter to get these probabilities. Let's go ahead and confirm that these 3 probabilities do add to 1. So I have 2/3 plus 1/12 plus 1/4. And you could do that in your head if you can do common denominators for all of those. And I get a probability of 1. So I have a valid probability model of all the outcomes, and I've got probabilities that add to 1. So now, what's the expected discount for a couple? Now, what this means is because, what's the average discount? So one couple is not going to get the average. One couple is going to get 0, 10, or 20. That's it. But if we took a whole bunch of couples and we kept giving them these discounts over and over and over again throughout the day at the restaurant, and we averaged all the discounts together, that would be the expected value or the expected average. So it's somewhere in the middle of 0 and 20, but you have to give a little bit more weight to the 0 because the 0 is going to happen more often than these other values. So it's not going to be exactly in the middle like 10. It's going to be some weighted average of all of these values. The formula for this is to sum or to add each individual outcome or each individual discount in this context times the probability. So the expected value, I keep writing a sum instead of an E, sorry. The expected value of D, that's how we can write it, or we could write mu D, both of these mean the same thing, is going to be each individual outcome or each individual discount times its probability added together. You do not need to memorize the formula. It is on the formula sheet. However, if you continue to work all these problems out that I am asking you to practice, you will most probably have it memorized. I go to my calculator. I type this data in. 0 times 2/3 plus 10 times 1/12 plus 20 times 1/4, and I'm getting an expected value of $5.83. So not quite exactly in the middle of 0 and 20, which would be 10, of 0, 10, and 20, because it did have more likelihood of the 0, so it got pulled closer to the 0 than being exactly in the middle. But over the course of the day, the manager can expect, on average, to give out about $5.83 per couple over the course of the day. So no individual couple is ever going to get that amount. They only get these amounts, but that's the average of all the discounts given out. I hope you realize, and we could do this in class, and maybe I will, I could use simulation to get this answer. You can always use simulation to get your probabilities. If I were to set up using like a random number line, picking numbers, picking various numbers, it would be a little complicated because of the probability having to change. But if you kind of consider it, or if we actually did it, if we actually got the 4 clubs and 4 cards and went around and everybody played the game and we just kept track of everybody's discount, in the long run, this is what we would get as an average if we took everybody's discount and averaged them together. So if we only did it 20 times, we might not get the exact average, but we would start getting close.